The job of a power company is to provide its customers with a reliable source of electricity. In order to accomplish this task, a number of protective devices are used on distribution systems to protect the system and equipment from damage and customers from an interruption in service. What we're going to do in the last two parts of this program is to give you a basic overview of some of the protective devices used on distribution systems and give you a general explanation of how a coordinated protective system works. We'll begin by looking at two protective devices that are found in most distribution systems: circuit breakers and fuses. A circuit breaker is essentially nothing more than a large switch that can interrupt current flow through a line. When the circuit breaker is closed, the lines attached to the circuit breaker are energized. When the switch is open, the lines are de-energized. For the most part, circuit breakers are located inside substations. As you'll recall from the last part of this program, transmission lines supply a substation with electricity. The transmission voltage is changed to distribution voltage by substation transformers that supply electricity to a substation bus. The substation bus then supplies electricity at primary distribution voltage to feeders. In many systems, circuit breakers are installed between the substation bus and the individual feeders. Generally, there is one circuit breaker for each feeder. Let's take a look at a simplified drawing of a distribution system to see how circuit breakers fit into the scheme of things. On this drawing, we have a transmission line, a substation transformer, the substation bus, three circuit breakers, and three feeders. Again, for simplicity, we're showing the feeders as solid lines. In reality, the feeder is normally composed of three phase wires and a neutral. Most circuit breakers have indication of when the breaker is open and when it is closed. For our purposes, we'll use red to indicate that the circuit breaker is closed and the feeder is energized, and green to indicate that the breaker is open and the feeder is de-energized. The basic purpose of a circuit breaker is to protect its associated feeder from damage due to faults. Now, there are a number of different types of faults. For our explanation, we'll consider only a ground fault. A ground fault is a current flow path to ground that is not a normal part of a system's design. For example, under certain conditions, a tree branch coming in contact with a distribution line can cause current flow to ground. A malfunctioning component on a utility pole can also cause a ground fault. We'll return to our drawing and see what happens when a fault occurs on a feeder. Now, keep in mind that we've slowed down the sequence of events for our explanation. In reality, protective devices are designed to respond very rapidly in order to protect the system. At this moment, the distribution system is operating normally. All circuit breakers are closed and all feeders are energized. Let's suppose that a tree branch sways against this feeder, causing a ground fault. When a ground fault occurs, the current carried by the feeder has a flow path to ground that is not a normal part of the system's design. In most cases, this causes the circuit breaker to open, momentarily de-energizing the feeder. The other feeders and circuit breakers in the system will be unaffected by this action. In general, circuit breakers are designed to open and then close automatically after a specific period of time has elapsed. If the fault is temporary, as in the case of a tree branch swaying into a feeder, it usually clears fairly quickly. When the circuit breaker closes, service is restored and the system continues to operate normally. However, if the fault does not clear, the current carried by the feeder will continue to flow to ground. This will cause the circuit breaker to open again for a period of time and then close. In some systems, this pattern of opening and closing will continue until the fault is cleared. In most systems, however, the circuit breaker is designed to open and close a set number of times and then lock out. That is, remain open until it is reset manually. Circuit breakers provide excellent protection against damage due to faults on feeders. Circuit breakers can also protect laterals that are tapped off of feeders. However, in many systems, fuses are installed between the feeder and the laterals to provide additional protection. In this example, the feeder supplies a three-phase lateral and a single-phase lateral. This is what a typical fuse looks like. It consists of two contacts, one tapped off a feeder and the other connected to a lateral, and a hinged fuse. In the closed position, the fuse provides a flow path for electricity at a primary distribution voltage to flow from the feeder to the lateral. In the open position, the fuse separates from this contact and swings down, interrupting the flow of electricity to the lateral. Unlike circuit breakers that can open and close automatically, a fuse is designed to open and remain open whenever the value of the current carried by it exceeds its design capacity. In most distribution systems, circuit breakers and fuses are designed to work in a coordinated manner for system protection. We'll use a simplified drawing of a feeder with fused laterals to see how this coordinated effort is achieved. In this drawing, we have a circuit breaker connected to a feeder with three laterals. The laterals are supplying electricity to residential communities, office buildings, and industrial facilities. At present, the circuit breaker and fuses are closed, and both the feeder and the laterals are energized. If a fault occurs on the feeder, the circuit breaker will sense the fault and open, momentarily de-energizing the feeder and the laterals. If the fault clears, service will be restored when the circuit breaker again closes. The fuses will not be affected in any way. However, if a fault occurs on one of the laterals, slightly different events take place. When the fault first occurs, the circuit breaker will sense it and open. If the fault clears, service will return to normal when the breaker automatically closes. However, if the fault remains, the circuit breaker automatically shifts to a different mode of operation. The second time the circuit breaker senses the fault, it delays opening for a short period of time. The actual amount of delay varies from system to system. Regardless of the system, however, the delay provides enough time for the fuse connecting the lateral to the feeder to open. When the fuse opens, the faulted lateral is isolated from the distribution system. The circuit breaker will then open and close. When the breaker closes, service will be restored to all parts of the system except the faulted lateral. This process is known as sectionalizing, and it provides protection to the distribution system and its components against damage due to faults. It also protects the majority of customers serviced by the system against outages. Circuit breakers and fuses are just two of the many protective devices used in distribution systems. In the next part of the program, we'll look at some other types of protective devices. But before we leave the topic of circuit breakers and fuses, let's review some of the points we've covered. We said that circuit breakers are basically automatic switches that can interrupt the flow of electricity through a distribution feeder. Circuit breakers have the capability of opening and closing automatically, and when used as part of a coordinated protection system, they can operate in a number of different modes. Fuses are used to connect laterals and feeders. A fuse can interrupt the flow of electricity through a line, but in most cases cannot automatically close to restore service. In a coordinated system, Circuit breakers protect feeders from damage due to faults, and fuses protect laterals from damage due to faults in a process known as sectionalizing. Sectionalizing is simply the ability of a power company to isolate a part of a system that is faulted while continuing to provide service to the majority of its customers. We'll stop so that you can review the material in your text on circuit breakers and fuses and sectionalizing. And when we come back, we'll look at some other protective devices.